Hey guys. Okay, so today what we're going to do is we're going to talk about finding x when dealing with exponents. So step number one is we want to get the same base. Step number two, set the exponents equal to each other. Step number three, get x by itself. Okay, so when we deal with having fractions, we want to try and get things so there's no fractions in them. So I know that 1 over 8 has an invisible first power, and since he's in the denominator, we know he's negative. So that means that same thing as 8 to the negative first. Okay. Well, next, we want to try and turn in 8 into 2. Well, we talked about before of things being to an exponential power. Can I take 2 several times to get 8? Well, I know 2 times 2 is 4. If I take it times 1 more, what's 4 times 8? What's 4 times 2? That's 8. Well, how many times did I take 2 multiplied together? 3. So what I'm going to do is I'm going to leave my 2 to the x the same. That's going to be equal to, I want to do 2 to the third times negative 1. Because we still have that original negative exponent that we used when we brought it up from the denominator. I'm trying to make it look like a negative 1. So all I did was replace the 8 because 8 is 2 times 2 times 2. So what I'm going to do is go ahead and use my exponential rules that we're all super familiar with. And I know when I have a power to a power, I just multiply. So 3 times 1 is negative 3. Since my bases are now equal, I have x is equal to a negative 3. Alright, let's try another one. So I have 9 and 27. Well, 9 doesn't go into 27. But what can make 9 and 27? What number? 3. So 3 is, or excuse me, to get 9, that's 3 squared. And since it's got that original the exponent of x plus 1, it's going to still say x plus 1. (27) is 3 cubed. And we talked about exponents as, we talked about radicals being the numerator, the type of power. Since it's just 27, it's 27 to the first, and since it's square root, it's an invisible 2. Again, I have a power to a power, so when I do that, this stuff's going to get multiplied. So we have 2 times x and 2 times 1. So I have 3 to the 2x plus 2. 3 times a half is just going to give me 3 over 2, or 3 halves, or 1.5. Well, now because my numbers match up, I can let my exponents be equal. If you don't, we're just going to change this to 1.5. So I subtract my 2. I get negative 1.5. Yes, no. I lied. You're not getting negative 1.5. I get negative 1/2. I knew that didn't seem right. Get negative 0.5. And I take that divided by 2. And x is negative 0.25. Okay. Sometimes my x is not always by itself. So because I have 4 with my x and I have a number over here, I gotta solve for x. So to do that, I divide everything by 4. So I get x to the 3/2, which is equal to 8. I feel like I skipped a one. Nope, okay. Then you're like, hey, how do I solve for x? What you're going to do is you're going to do the reciprocal. So the reciprocal means the flipped version of it. So if I am taking it to 3/2, I'm going to multiply by 2/3 because I want it to be equal to 1. And what did I do to one side? I did to both sides. So I get x is equal to 8 to the 2/3. In my calculator, I'm going to hit 8 up caret 2 divided by 3. So x is 4. And I want to check to see if I can simplify to get a number. And I did, so woo! I need to pick some more colors. Alright, and this next one, I'm going to scoot over a little bit. Oh, definitely cannot scoot it. Okay. I want to get x by itself, so the first thing I have to do is add my 2 to both sides. So I have x minus 1 to the negative 1/4 is equal to 2. My Xbox just turned itself on. I think my cat did it. That was weird. Okay. I want to get rid of the exponent now because I want to get to x. So I'm going to multiply by the opposite of what I see. So I have 1/4, so I want to multiply by 4/1. And because it's negative, I'm going to throw the negative on with it to cancel it out because I want it to be positive. If I left just the negative and didn't multiply by it, what would happen is it would change. It wouldn't make it go away all the way. I'd still have a negative exponent, which we don't want that. So I'm left with x minus 1 is equal to 2 to the 4/1 is just negative 4, which we know we have to move to the bottom to make it positive. So I'm going to take 2 to the 4th, which is 16. I'm going to add 1. So when I do that in my calculator, I'm going to do 1 divided by 16 plus 1, and then I'm going to my math bracket to turn it into a fraction. So math frac essentially is you're going to hit the math button that is right under alpha. It's the green button. And the very first one is FRAC, which is saying fraction. So it's saying, do you want to turn your answer into a fraction? You're going to hit yes, so you're going to hit enter. So in this case, your x is 17/16. I want fractions. All right, let's take a look at some more. All right, again, we cannot do 2 and 8 yet, but I know that 8 is 2 to the 3rd. So I have 2 to the 3rd. So the x is equal to 2 to the 8. So I have 2 to the 3x is equal to 2 to the 8. So since my bases are equal, I get 3x equals 8 divided by 3. Again, it's not a pretty answer, so just leave it as a fraction. All right, I've got 9 and 81. 9 and 81. Can I turn 81 into 9? So I have 9 to the 4x is equal to 9 squared. In this case, I don't have anything else that's already to the exponent, so I just can leave it there. So now that they're the same bases, I can say I have 4x equals 2. Divide both sides by 4, I get x is a half. Ooh, look, 8 and 2. 8 is 2 to the third. We should be getting used to seeing that. We will see it a lot. So because I have a power to a power, I'm going to go ahead and multiply those through. So I have 2 to the 3x minus 3 is equal to 2 to the x plus 1. Hey, look, I have the same bases, so now I have 3x minus 3 is equal to x plus 1. Well, I have x's on different sides, I have numbers on different sides. There's 4 different ways to start this one. I like to deal with my x's first, so I'm going to go ahead and get them over there. So I have 2x minus 3 is equal to 1. I'm going to go ahead and get rid of that negative 3 by adding it. So I have 2x is 4. Divide both sides by 2. And x is 2. Alright, I want you to try these two. Just kidding. I lied. They're pretty scary. I honestly thought that one got changed. I think my thing's out of order. I'm not gonna lie. We'll go with it. So, since I don't have the same bases with this first problem on the right side, I need to try and get it so it's one term by itself. I know I can turn 4. I know I can turn 4 into 2. So what I'm going to do is I'm going to change to try and get the right side so it's all equal to one term. So I have my 8x. I have 2 to the 8, and I know that 4 is 2 squared. And that 10 is still hanging out there. So I have 8x is equal to 2 to the 8 times 2 to the 20, because 2 times 10 is 20. Now that those are the same bases, I can go ahead and add the exponents. So I have 8 to the x is equal to 2 to the 28. Now I need to get the same bases on both sides. Well, hey, we've already seen 8. 8 is 2 cubed. So I have 2 to the 3x is equal to 2 to the 28. Since I have the same base, I can go ahead and put my numbers together. So I have 3x is equal to 28. Divide both sides by 3. X is 28 over 3 because it's not a nice pretty answer, so we're going to leave it as that ugly fraction. Alright, this guy. 9 and 27. Well, we've already seen 9 and 27. What magical number did we use? Where was that? Oh, hey, wait, that's not it. We're going to use 3. So we're going to turn these into 3s. So 27 is 3 to the third, which is 1 minus x. Now we know that because 9's on the bottom, he's 9 to the negative first. So I have 3 to the 3 minus 3x. 9 is 3 squared. And I have to the negative first, so he's a negative 2. So I have some multiplications going on here. Since I had 9 to the negative first, and I replaced it with a 2 to get 3, because 3 squared is 9, I take that 2 times that negative 1, and that's how I get the negative 2 here. So now I need to go ahead and simplify some more. So I have 3 to the 3 minus 3x. Oh, come on. Is equal to 3 to the negative 6 plus 6x. Hey, we're the same number now. So because they're the same, I can go ahead and say 3 minus 3x equals negative 6 plus 6x. Oh, what up, bitches? Okay, so again, 4 different ways to start it. I'm going to go ahead and add my 3x. So I have 3 equals negative 6 plus 9x. Add 6 to both sides, I get 9. So 9 equals 9x. Divided by 9. And x is equal to 1. Okay. So when x is a variable, you want to get x by itself. And you want to multiply by the reciprocal of the exponent, which again is why I'm pretty sure this is out of order, and I don't know how it got out of order. So there's your rules if that's what you're looking for. So what we're going to do here is we're going to go ahead, like what we did in a couple of the examples before, is multiply by the reciprocal so we can get x by itself. So, I don't know why he's giving me weird colors. Since it's to a negative 2, I'm going to multiply by, now 2 is 2 over 1. I'm going to multiply by negative 1/2. As an exponent, not taking it times negative 1/2. To the exponent. So that gives me 8x. Pooey. It's equal to 64 to negative 1/2. Well, since he's got the negative exponent, he's got to go down on the bottom, become positive 1/2. And we know that rational stuff, the ones with fractions and the exponents, are essentially, you do this too for noise, they're essentially this radicals. So it's going to be the second root, so the square root of 64 to the first. And the square root of 64 is just 8. So I have 8x is equal to 1 over 8. So to get x by itself, sorry, I gotta scroll up, pictures in the way. I'm gonna go ahead and divide both sides by 8. And when I divide over here by 8, it's like actually same times 1 over 8. My answer is 1 over 64. Alrighty. So since the one before had the exponents around everything and this one doesn't, I actually have to get rid of my exponents first. So I'm going to divide everything by 8. Excuse me. Since it had the parentheses around everything over here, and it doesn't over here, I have to get rid of my constants first. So that's why I have to get x by itself. So that's why I have to divide by 8 first. 64 divided by 8 is 8. So now I'm going to take it to the negative 1/2 again. So I have x is equal to 1 over 8 to the 1/2. The 1/2 power is just the square root of 8. And 8's not a perfect number, so I can't break him down. Alright, last guy. Again, since my -2 is with the parentheses, I can go ahead and do that guy first. So to the negative 1/2. So I have 8 plus x is equal to 64 to the negative 1/2. And we've already found what negative 1/2 is. It's 1 over 8. We already found that. We proved that in the problem above, or the problem before. So if 8 plus x is equal to 1 over 8. Since 8 is positive, I'm going to go ahead and subtract him. So I have this is how I'm going to plug this one in my calculator so I can keep it nice and pretty. I have an 1/8, which is just a division problem. So I have 1 divided by 8 in parentheses minus 8. And then I'm going to do my math frac so that I can keep a nice pretty answer. And I think that negative 63 over 8 is more clean than if I were to, I don't want the fraction, negative 7.85. Again, getting up in math, we want fractions. Alright, see you tomorrow.